steady state runs a simulation for a very long time and theoretically infinitely. Just now we ran model 7-1 as a terminating simulation. Now assume we want to have steady state simulation. Many models start from zero and idle. In a steady state simulation, this could lead to bias in result analysis. To handle the initialization bias caused by zero start, we can introduce a warm-up period. The statistics will start collecting data after the warm-up period. The questions are, how long should be the warm-up period and how long should be the run length? Let's try a few ideas on how to determine warm-up period and run length. Model 7-2 adds a dstat to find out the work in process WIP and output it to a .dat file for output analyzer purpose. Let's run it for 5 days and 10 replications. In output analyzer, let's open total WIP history.dat and plot it. The figure shows the WIP of all 10 replications. It looks like things settled down after 2000 minutes. If we run it up a little, we may select 2 days as our warm-up period. If it is as obvious as model 7-2 to identify warm-up period, we may just make replications as the same way as for terminating simulation. This is called truncated replications. That way, we don't have to run simulation for a very long time. Given this observation, we modify model 7-2 to model 7-3 with warm-up period of 2 days. We also delete output file because we don't need it anymore. The total WIP result of model 7-3 has a larger half-width compared to without warm-up period. It seems that warm-up period impacts the result a lot. If a model warms up slowly, we may have to run one really long run. For analysis purpose, we may break output from the single run into a few large batches. For each batch, we want to get tallies and a dstat. We then take the average of these batches as batch means. Model 7-4 has one replication of 50 days with only single 2-day warm-up period. This is a steady-state simulation run. This time we save total WIP in a .dat file again. The result .dat file is plotted in output analyzer. Now the question is how to choose batch size. Arena uses some internal rules for batch sizes. Basically, we need to have sufficient data in order for Arena to calculate the batch means confidence intervals. If we run model 7-4 and check its crystal reports, we can find the average WIP and its half-width in the category overview. This is considerably smaller than the half-width obtained from truncated replication. This chapter introduces steady-state simulation and its analysis very briefly. We suggest you avoid using steady-state simulation unless it is absolutely necessary.